Let's look at the solutions to the sample exam, one question at a time. The first question, we want to look at two linear transformations defined as such. And in part A, we want to let B equal the matrix that represents the linear transformation L sub B. And we want to determine that matrix. So, to determine the matrix, we know that the first column is described by how the output, if we input the unit basis vector 1, 0, 0. So the first column of B should be 3, 1, 0. The second column is the output when the vector 0, 1, 0 is inputted. So the second column should be negative 2, negative 1, 1. And the last column should be 0, 1, 2. Since that's the output when we input the unit basis vector 0, 0, 1. Now, we're supposed to let C equal the matrix such that C times X is L of A of L of B of X for all X in R3. So if X is a vector of size 3. Now, let's see. L of B is described as such, and L of A is described as this. So if we input the vector 1, 0, 0 in for X, L of B becomes 3, 1, 0. But 3, 1, 0 maps to 2, 1 by L of A. So I know exactly how to determine the matrix C. It's going to have a first column 2, 1. The second column is going to be found by inputting for X 0, 1, 0. But L of B maps that unit basis vector to negative 2, negative 1, 1, which L of A maps to 0, 1. So that's the second column of C. And there is a third column of C that will be 1, 0 because the unit basis vector 0, 0, 1 gets mapped to 0, 1, 2, and 0, 1, 2 gets mapped to 1, 0. Notice that this is a matrix that's a 2 by 3. Now, I could have answered the first part of this question first, but I decided not to. What are the row and column sizes of C? It's a 2 by 3 matrix. How did I know that? It's basically because the size of the input was a vector of size 3, and the output is a vector of size 2, so I knew it was a 2 by 3. But describing it, it was easy to see that there were 2 rows and 3 columns in the solution. So, our first problem